All right, what am I going to talk today about? So I'm going to talk about optimizing applications for scalability, so as like one of the for me, more important points, while keeping costs at bay. So I'm going to talk a little bit about some techniques and some things that sometimes are overlooked to keep costs in control. One warning in the beginning, this will be a somewhat opinionated talk. So I made choices on the products that I showed today. There are many, many more products out there. This is really a talk where it's like, okay, if I would build an application that I want to be able to scale and still be in my budget, these are the products that I would choose. So I will concentrate on that as like basically a side note for you, that you know, like if there are products missing. What am I going through today is I give a little bit of introduction, basically terminology that I use, and then I go through the full stack of my application, so presentation layer application, persistence, logs, analytics, and then talk a little bit about related session and resources where you can find information. A bit about myself, just 2 words or maybe 3. I'm a cloud developer advocate for the Google Cloud Platform. So basically, we are the interface between developers and operators building on top of our platform and the developers and operators that build the platform inside the company. So we are your voice into the company, and we are the voice of the engineers outside. So please feel free to reach out to me if you have things where you think like we can improve, where you have challenges. Also, if you have good stories and you just want to tell us about it, how amazing certain things are, please reach out to us. We want to relay that back to the engineering team. So you can find me, for instance, on Twitter under the name @HostyRusty. All right, just a little bit of a pulse check. Who is here today? Like, who's an engineer in the room? All right, majority, that's my audience. CXO, ITDM. Okay, so most engineers. So what are the criteria that I go through today when I'm looking at some of the products of the Google Cloud Platform? So first of all, I'm going to look at performance. And performance, what I understand under that is basically the response time, like how quickly an application responds, especially if you are in the upper layers of your application. You want to have things being snappy. So you want to have like very low latencies in terms of round trip times and low like processing times, so to say. It's especially important in human interactions. They don't want to wait for a second or even half a second till something loads up, right? Second point, which is important for me, is reliability. So what happens if there is something that fails? Is there like a failover? Is there some redundancy there that can help me to like have my application still up and running even if parts of my application fail? The third part, and that is part of the title, is the scalability. So what happens if my application goes viral and like my user base grows? Do I have to re-architect completely? Do I have to change system, change products that I'm using, or can I just use them from user 0 to user 1 billion? And last but not least, also part of the title are the costs. Now, costs are not only the costs that you get charged on your credit card, or if you're having offline billing with us installed, you have to pay per like bank wire probably. Not only these costs are considered, you should also consider costs like migration costs like of operation. Like what is the human labor that your company has to put in to manage certain systems, right? So yes, there are systems out there that are cheaper than others, and it looks like, why would I pay more? But the labor cost adds up, and so you should consider that as well. That's why you see in the cost section not only the money back, you see also the people involved there. And I will make a couple of statements along those lines along this talk. All right, so what do I understand under a full stack application? You saw it in the agenda already. So I, for myself, consider a full stack application being a presentation layer, so basically assets that I serve. Then an application layer, which basically has my business logic and processing, and a persistence layer, which is basically my storage, a database, things like that. On the side, I have onto one side like service APIs, so things that you can call out into the Google Cloud Platform or even like other providers or even on-premise. And on the right side, you have like logging and analytics, which is integrated in a lot of our products, but you can also integrate that into your applications that you're writing. All right, so let's start with the presentation layer. So my choices of presentation layer, I'm a big fan of Firebase. Firebase makes it really easy to start coding, getting something up and running. And part of the Firebase platform and ecosystem is the Firebase hosting. So you see on the right side there, you have like a portfolio of things that you get out of the box with Firebase, being like authentication, a database, a NoSQL database, Firestore, blob storage, cloud functions for processing, and hosting for like hosting static assets. Now, it's very easy to get started with Firebase, but Firebase has also very simple cost structures. And so that might mean at some point, if you are at a certain scale, that there are more affordable solutions out there for you to save some costs. So my second choice here is, especially if you're looking at scale, is cloud storage and cloud CDN. So what am I looking at in terms of like the 4 criteria that I mentioned before? So if you look at performance, we're good, right? They are snappy, like CDNs, like Firebase hosting is also backed by a CDN. So they are basically at the edge points which we have around the world for Google Cloud Platform. So low latency is great. Reliability, static assets are easy to replicate. Right? So you cache them everywhere in the edge cases. So even if one of your edges falls down, or multiple even, they can be fetched from other edges. So we have replication, so we are also reliable on that. Scalability, again, you don't have like strong consistency constraints with static assets. If you have higher ones, you can set your cache timeout basically low, so like that. The cache is refreshed more frequently, but basically, since it's static assets that we can replicate, scalability is not an issue either. And when it comes to cost, I mentioned already, Firebase is kind of like a static cost, and cloud CDN, cloud storage are a little lower. So what does it mean in detail? What are the cost drivers for my presentation layer? So one of the big cost drivers is egress. So egress is basically all the bytes that we ship out of the Google network to your clients, to your customers. These are the things like where you have to look into, and they become, again, in Firebase you have basically flat rate. For small installation, that is fine. There will be like a low difference between the solution that you use, but if you go on a larger scale, then egress actually goes down depending on the traffic that you have. So increased traffic, you get basically down in what you pay per gigabyte for your egress. And that only gets, you can only benefit from that if you use Google Cloud Storage. Now, if you want to go even lower in your prices that you pay for egress, then you can use a CDN in front of cloud storage, which incurs a fill-up cost. So you have to basically ship some data into the cache. You pay that. But then the egress cost from the CDNs is quite a bit lower than like if you compare it, for instance, with serving data directly from cloud storage. So if you are large scale, please look into cloud CDN. And in front of Google Cloud Storage, this will be much more affordable than if you look at standard Firebase or just using cloud storage. Now, the second one is my application layer. And for the application layer, I chose like 3 kind of categories. So Cloud Functions is available on GCP, also on Google Cloud Platform, as well as under the Firebase umbrella and branding. So you can use it directly from your Firebase applications. You can trigger them from like HTTP. You can trigger them in Firebase, for instance, if you have any data changes in your NoSQL database, in the real-time database, or in Firestore that is available under Firebase. So if you have any data changes, you can automatically trigger your Cloud Function. Cloud Function under GCP, you can also trigger when, for instance, on a PubSub message. So PubSub is our messaging system, which is scalable beyond belief, at least my belief. You don't have to do any kind of sizing or anything decisions. You just pump data in there, and it will arrive at the destination where you want to have it. And that is globally as well. So that is also a trigger that you can use for Cloud Functions. And another trigger that you can use is any kind of storage operations. So for instance, if you use Cloud Storage, which is our blob storage, if you store a file or modify a file, you can also trigger Cloud Function to do any kind of post-processing if you want to. The second choice for my application layer is App Engine. So App Engine has a couple of really nifty and nice features. It's scaling down to 0, for instance. It's flexibly scaling. So there are like some comparisons that you can draw between Cloud Functions and App Engine, but there are also some differences. And then the third choice is basically Kubernetes Engine, which is running containers. So it is our managed Kubernetes. So Kubernetes is a container orchestrator where you can run your containers, and Kubernetes takes care of restarting them if they fail. It's taking care of node management, resource management, things like that. You can install a service mesh in Kubernetes to have like discoverability, have security in there, things like that. So there are a lot of more things that you do manage yourself in Kubernetes, which are managed for you in, for instance, App Engine and Cloud Function. So let's have a look at our 4 criteria. I know they all look green. I have a couple that are not green, just to mention that. But basically, if you look at Cloud Functions, like performance, reliability, so Cloud Functions, unless it's like the very first call, which takes a little bit of a warm-up, but if you have follow-up calls, then they are really snappy. They're like in like low tens of milliseconds, depending, of course, on your processing, like how much processing you do in your Cloud Function. But if you, for instance, just return a hello world, you can get into the tens of milliseconds in response time. In terms of reliability, Cloud Functions is running on our infrastructure. It is also like basically you just can scale very easily containers, and if one falls down, we can just reroute the traffic to another one that is alive. And they are in a region, so they can be brought up in different zones. So even if a zone becomes unavailable, your Cloud Function is still available. In terms of scalability, I mentioned, I say there like order of seconds. So if you have to warm up new instances of your container, which runs the Cloud Function, it is usually at the order of a very low second range. Now for App Engine, it's very similar story. So App Engine has certain constraints in terms of like processing. If you have a front-end processing job, it's like constrained to like 60 seconds. After 60 seconds, we basically time it out. In Cloud Functions, you have 9 minutes to process. After 9 minutes, we basically stop the function processing. So these are boundaries that you have to consider if you do certain kinds of business logic. For App Engine, we have background processes which are allowed to run much longer. I don't have the exact number right now, but they are allowed to run much longer if you need to do some asynchronous background processing. Now for Kubernetes, if you're inside the cluster, you still have resources available, then you can scale at the order of milliseconds. So bringing up a pod is pretty fast unless you do a lot of warm-up initialization in your pod. But I'm a big fan, for instance, of writing Golang apps nowadays. And I statically link these binaries and put them in my container. That makes the containers very small, so even if they have to be fetched from a registry. And then they are started up like in milliseconds, like really, really, really quick. Now, if you run out of resources in your Kubernetes engine cluster, you need to scale the cluster. And that is basically adding compute engine instances, and that is at the order of minutes. So it takes about 30 seconds to bring up a compute engine instance, and then it takes about another 30 seconds to basically set up the whole Kubernetes stack, which we need to manage that node. Now, the advantage of Kubernetes is also you don't have any kind of like runtime restrictions there. So you basically run your container, like it can run whatever you want in there, what basically runs on the Linux kernel. You can run your container on there, and you don't have like restrictions like how long it can run and it gets stopped or things like that. Now, what are cost drivers for Google Cloud Functions? So GCF, Google Cloud Function, GAE is Google App Engine, GKE is Google Kubernetes Engine. What are the cost drivers here? So for functions, you have basically an instance type that you can choose. It's memory and processing power based, so CPU hertz based. You see there it's from 128 megabytes to 2 gigabytes. Based on the size that you choose, you have a certain cost per second for that instance. And then it's basically also a call count, like depending on like how many calls you have, we basically time like how long your function is running, and then we calculate the cost there. in all of those, what's coming in is the egress as well. Now, the advantage of the egress for these ones is that for Cloud Functions, it's a baseline. So you basically pay the same no matter if you call it once a day or 100,000 times a day or 1 million times a day. For App Engines, it's the same. Now, for Kubernetes Engine, we price the egress based on our standard networking prices. And the networking prices is based in the sense of that the more traffic you have, the lower the price goes for egress. So consider that if you have a big an application which gets viral, your application will become cheaper over time the more traffic you get if you run it on Kubernetes versus App Engine or Google Cloud Function. Now, one note to that, like if you run Kubernetes, even if you run Kubernetes Engine, the managing of your applications on Kubernetes will incur labor costs. So you have to consider that. Now, yes, you have that also with App Engine. You also have that with functions, but there are a little bit of difference in the magnitude how much labor cost management is there. Now, for the sizes, basically, if you have jobs which require a lot of memory or a lot of like CPU power, you are out of luck pretty much in GCF and GAE. They are like capped for Google App Engine at 1 GB memory, for GCF at 2, and at 2.4 gigahertz of processing power. Now, for Kubernetes Engine, you basically can take big machines, like take your 64-core machine with 2 terabytes of main memory, and if your pod needs a terabyte of main memory, so be it, you can do it. So consider that as well. If you have some really like heavyweight processing, you might want to go more to a GKE-based system than something else. All right, number 3, and that is basically my big passion as a Google developer advocate for the cloud platform, is the persistence layer. So now we have a couple of different types of persistence products there. The first one that you see here is cloud storage. So cloud storage is basically a blob store. So if you have any kinds of objects that you want to store, any kinds of assets, then cloud storage is what you want to use. Cloud Firestore is our NoSQL document database where you can store data without having to predefine a schema. And it's very flexible in terms of it can grow in terms of processing as well as data very flexibly. Cloud SQL, you have like basically a managed MySQL or Postgres, and Cloud Spanner is our relational database system, which is horizontally scalable. Now, if we look at cloud storage and Firestore in terms of reliability, scalability, performance, they are pretty snappy, they're very quick. The really nice feature of cloud storage is that the listing is strong consistent. So if you add a file to cloud storage and you are at the other end of the world and you ask if that file exists, it will give you a strong consistent view. If you look from 2 places in the world, let's say it this way, if you look from 2 places in the world at roughly the same time, you will get the same view of what the data you have in cloud storage. That is not true for a lot of other systems that are out there in the world. In terms of scalability, they're very scalable, these systems. You don't have to look at sizing or anything. You basically start from 0 and it grows with your application. You don't have to worry about, you don't have to give us any sizing information or any of this. Now, if your app gets really, really viral, like I don't want to name the company, but there are certain companies that build their whole business on App Engine and Data Store, which is the predecessor of Firestore. Now, if you get at that like $1 billion valuation kind of scale, please still talk to us. We want to make sure that your business runs reliable and gets the performance that you need. So we give you some dedicated resources for that. Now, if you look in the relational database area, we have Cloud SQL and Cloud Spanner. Now, that's where my first non-green check marks are coming, or crosses. If you look at Cloud SQL in terms of like reliability, now Cloud SQL is out of the box basically a single host system. So if this system falls down, you become unavailable. So you don't have necessarily out-of-the-box replication. Now, what you can do with Cloud SQL and the Google Cloud Platform is you can actually set up like a failover instance, and you can set up reader replicas to get a little bit more scalability out of your system. But even if we have to fail over to your failover database, it will incur a little downtime. It will take some time to basically catch up with the logs and stuff like that. Now, if you look at scalability for Cloud SQL, for instance, you can upsize your Cloud SQL instance, so you can scale it vertically. You can jump between different sizes of instance sizes between Cloud SQL, but they are at some point capped, right? You have a maximum instance size that we can support, and if you outgrow that, you're out of luck pretty much, unless you are building your application on top that can manage to distribute your application workload across multiple Cloud SQL instances, for instance. But even if you upgrade your instance, then you are at the order of at least minutes, if not hours, to basically do that upgrade. And your customers can't access or do things with your application during that time. Now, if we look at Cloud Spanner, this was designed with the idea in mind to actually eliminate these boundaries, eliminate the boundaries of scaling, and eliminating the boundaries of having maintenance, even if it's planned maintenance outages. Now, Cloud Spanner is still, even though it gives you the quality, still a relational database with strong consistency. So we have strong consistency across tables, regions, and even globally that you get there. And you can do no downtime updates. So you can basically add nodes or remove nodes from Cloud Spanner depending on your workloads. And you can also update your schema, which is running inside a transaction as well, even while you are serving live traffic. So now what are the cost drivers for cloud storage, Firestore, SQL, and Spanner? So for cloud storage, it's basically the storage and egress. For Firestore, you are charged based on the operations, the storage, and again, egress. You have heard that by now a couple of times. Cloud SQL, based on the instance type that you choose, and if you have a failover instance and read replicas, that basically adds to the cost as well. So if you want to have high availability and disaster recovery, that's basically what you pay for. And Cloud Spanner, we charge you based on the configuration that you use. So configuration is basically, do you want to have a regional instance? Do you want to have a multi-region continental instance? Or do you want to have a multi-region global instance? Based on that, we charge different amounts of money per node that you provision with us. And then, yeah, basically the node count that you choose is what drives the cost. And again, also we have egress costs there that you incur. Now, how can you optimize on these levels? So one optimization that is many times overlooked in cloud storage is the storage classes that you have. So the storage classes is we have a multi-region storage, we have a regional storage class, we have nearline, and we have cold line. And especially if you go to nearline and cold line, the storage cost at rest goes down a lot. Now, there are certain things we can, of course, like storage costs go down, but we cannot just like lower the prices without giving some constraints on these. So if you go to nearline, we recommend, like, if you have data that is not accessed more than once a month, then it's worth to move your data to nearline. If you access it more than once a month, then you will actually incur more costs because we give a little bit of penalty for retrieval of data if you use nearline. Now, code line is basically for something where you want to have archival or like backups that you don't hope and expect to use. So cold line is or something for legal reasons that you have to store for a long time. Cold line is if you access data less than once a year. So if you access data once a year or twice a year, like cold line is already more expensive than a regional instance. Now, the really cool thing in Google Cloud Platform for Google Cloud Storage is that these storage classes are not, or you can define buckets. So you can define buckets where your objects go in, and then all your data that you go in goes into that bucket, gets that storage class. But that's not the only way to have storage classes for your objects. You can actually use one bucket and have different storage classes for the object in a bucket. And so there's something called object lifecycle. And for the object lifecycle, you have the option, for instance, say like, okay, if that object is not accessed for, like, say, 30 days, please move it to nearline. If it hasn't been accessed for like 365 days, please move it to cold line. And you could define these policies, and this is done automatically for you. So you don't have to, like, you define these policies once, and then you say, like, I'm off the hook. Over time, the data that I'm storing, it's going to be getting cheaper for me. Right? So you don't have to keep that at top of the minds. Okay, like I have to run like a run job that basically moves these objects. Now, another thing that you can do that I did in a demo at I/O is, for instance, if you have certain blobs that come in, like videos or images or something like that, that you do a processing of. So you do, like, for instance, generate thumbnails, or you do a redecoding of your videos or things like that, and you want to keep the raw image or raw video footage around, but you know you're not actually serving that very often. You can, right after you process your data, you can change the storage class of that raw object. And you basically say, like, okay, I'm processing the data right now. Once the last process is finished, I move it to cold line, and you're done. Right? So you can do that on with our client libraries and our APIs as well. So you can do that programmatically. Now for Firestore, what I recommend to basically keep costs under control, look at using limits, like how much data you get returned from your queries. Look at cursors and offset. So basically, you can use a cursor if you do paging, that you only really get the data into your application and presentation layer that you're actually serving to your customer or to your user. Don't like get all the data and do some processing. If you do that every time, you incur basically a lot of costs on these operations. So we have costs attached to reads, writes, and delete operations on Firestore. And another recommendation is to do analytics outside. So consider if you store data and you use it operationally in Firestore for your application, if you do want to do analytics over your data, consider moving that data out, for instance, into BigQuery. For Cloud SQL, things to basically look out for, like keeping costs under control, use the right size, the right instance size. Of course, like do a projection where you're gonna grow so that you don't have to change the instance size every month. And like how your traffic pattern is. But the instance size is basically your granularity that you can choose to have costs under control. And then you have things like failover and read replica. So don't just like right away create a read replica if you don't need it. So there are certain capabilities of your Cloud SQL instance out of the box where you don't necessarily need a read replica. So read replica comes in if you hit basically the boundaries of your Cloud SQL instance in terms of like write and read throughput. If you want to get a little bit higher in the write throughput, you can consider a read replica, which will take away a little bit of the work from your master or leader node. And then you can, with that, get a little bit more headroom in the write throughput on your instance. Now for Cloud Spanner, we recommend to scale depending on your traffic, on your workload, basically. So do some tests, like watch how your traffic is for your application. And you are charged on a granularity of an hour on Cloud Spanner. So don't do scaling like every 10 minutes. So basically do a little bit like space the scaling a little bit out. So you pay for a node anyway for an hour. So consider that if you program any kind of scaling for your Cloud Spanner instance. All right, number 4 is logs and analytics. And before I'm going to go in logs and analytics, I want to show really quick, I mentioned Cloud Firestore, and I want to show a little demo at least for Cloud Firestore. So I'm going to switch to my laptop here. And some of you might have seen it already. We have it as a showcase demo. So basically what I wanted to show with Cloud Firestore is it's very easy to keep multiple applications on different platforms, an application on different platforms and devices in sync. So we allow something that you can watch for data changes in Firestore. This is a feature that we had for the real-time database under Firebase. And so what you see here is basically the console for Firestore under Firebase. And you see here we have a database one, we have some data, we have some rules, basically who can access the data. You can define indexes or remove indexes if you want to, and you can see the usage basically of like how much data we're processing. Now in this demo, what I wanted to show is the scalability that it's possible with Firestore. So the demo is I have devices which are watching a document. So I'm going to show you really quick this document. We have basically here a document that can change a color. Every time I change a color, 10,000 imitated devices are catching that data change. They get basically notified about the changing color. You just saw it changing. They get notified about the changing color, and once they get that, they write that back actually to Firestore. So this color that you see here is in my input document. So I have 4 input documents. I split up basically the Firestore logo into 4 pieces. And then you see here a color and a timestamp. And every time we see a change, these devices report that back to the database. Now, how do I want to visualize that? The way that I'm visualizing this is I actually have here on the left side the Firestore logo. And each pixel, each color pixel is represented by one device. Now, if I change the color you see here, the color change gets basically propagated to these 10,000 devices per section. In total, we have 40,000 devices. Every time a color changes, they get basically propagated, and then I display that in my display app. And I didn't have to do anything for that in terms of like looking like how do I notify my devices or things like that. I just use the client libraries, and all this is done automatically for you. Right. The next thing that I want to talk about a little bit is logs and analytics. So we have a couple of products there that help you to analyze your usage patterns, your data that you are collecting, that you want to analyze to, for instance, to machine learning, to get insights into your business, to find out like what works reliably and what doesn't. So the products of my choice here in that area are BigQuery, which is basically a relational database for massive scale data analytics, and I'll show a little demo in a second. The second one is Cloud Dataflow. Cloud Dataflow is a data processing infrastructure and basically platform where we have a library or basically a programming model that we open sourced under the Apache Beam umbrella, which allows you to write data processing pipelines that work both in streaming mode and in batching mode, which is very powerful. And then if you have already any kind of existing data analytic pipelines, for be it like in Apache Hadoop or in Apache Spark, you can run these basically and migrate them basically in kind of a lift and shift manner and run them on Cloud Dataproc. So now if we look at all these metrics again in terms of scalability, reliability, and performance, well, they are not end user like infrastructural products that you use. You don't use these products to serve something directly to your users. So don't use BigQuery if like directly connected into your application. If you use BigQuery, please cache, do some caching on top of it. Otherwise, your users have to wait a little bit of time. So query runtimes in BigQuery are usually at least a second. Right? They're like, this is not a real-time, like fast answer query machine. And that's just by the nature how BigQuery is designed. Now for Cloud Dataflow, it's pretty similar. Like for data going through Dataflow, it incurs like some latencies. So you don't want to rely on that either. Basically, these are async system to use in an async manner. And then Cloud Dataproc, as mentioned, is a system for you that you can use Apache Hadoop or Apache Spark on it. And they're like in terms of scalability and performance, they are all built on Google Cloud Platform, on our infrastructure, and we make sure that these are up and running. Especially like if you look at BigQuery, I haven't like they're running on so many machines. Even if a machine falls down, another one picks up the work, and it's similar for Cloud Dataflow. Now, what are the cost drivers for these systems? If you look at BigQuery, it's basically scanned data or like what your query touches in terms of data. Storage, which is very reasonably priced. It's pretty much priced on nearline and cold line prices for cloud storage. So you can actually keep your data in BigQuery, and you don't have to move it out into cloud storage or move it back in. BigQuery has also a federation mode, so you can actually use data that is directly stored in cloud storage and query that data. Now, we don't have the data storage optimizations there, so queries will be a little bit slower, but you can, if you want to, directly query data that is laying in cloud storage. Now, for data flow, you pay for per virtual CPU, so you pay a GCE instance, and then the virtual CPU, you pay like how much memory you want to provision for that. You pay for the storage that you use and the data that you process, basically. We have some cool services under data flow. So we have a shuffle service, which is outside of your instances, which uses a novel way of shuffling your data, which can free up a lot of like the size requirements on your instances. So if you use our shuffle service, you need smaller instances to process your data. So you can save on that, and then you pay us a little bit for the shuffling service, which is also more performant and faster. On Cloud Data Proc, basically GCE instances that you use, so you can use the instances that we have available. You can also customize your instances for your pipelines that you want to use, and you pay a premium, a Data Proc premium on top of this per vCPU, per CPU, I believe. And what we charge is like at the minimum of 1 minute, but we charge it per second. And then the choice is basically what you have for saving costs, if you look right away on the Cloud Data Proc, is one, you can use preemptible VMs. So if your jobs allow you basically that machines become unavailable if we reclaim them, and your job can pick up these the work from a machine that we reclaim, then you can use preemptible VMs. And preemptible VMs are considerably cheaper than GCE instances that you basically can keep. So take that, consider that to optimizing your costs on the analytics side. For Cloud Data Flow, you have the possibility to provision standard persistent disk or SSD. So SSD is also considerably more higher price than standard PDs. So that's also something to consider based on your requirements of like how fast your analytic pipelines have to run. So that's something that you should test basically for your workloads. What is cheaper if you run with SSD? Then maybe your pipelines are shorter in the time that they need, and you can you pay less for the instance cost, but a little bit more for the persistent disk. So that's something that you should check on your workloads. And for BigQuery, what we optimize is what we recommend for optimization is run your queries on a small data set first. Make sure that your queries are optimized on a small data set. Don't run them on your entire data set. You will incur a lot of costs every time. So run it on a small data set, optimize them that they read as few of data as possible, and then you can run them across your entire data set that you want to do. And then another option is you have the choice between on-demand and flat rate billing for BigQuery. So consider if you are running a lot of BigQuery queries or jobs, then consider our flat rate pricing, which can help you as well to save some cost. All right, let me show you. Let me show you a quick demo for BigQuery. I just want to show you the sheer amazing amount of data that it can crunch in a little bit of time. So here, what I'm going to do is I want to look at all the Wikipedia articles that have happiness in their title from 1st of July till today. So I'm going to run this job, and that goes against the data set that we basically have in terms of page views on Wikipedia, which is updated constantly. And you see here we have like a 9-second query for 130 gigabytes of data. Well, that's cool, 9 seconds, 130 gigabytes is maybe not that impressive. Let's see how that is if we look over the entire year so far. So it's from 1st of January till today. Again, you see there in this query that I'm actually doing a regex. Now, I'm caching. I don't want to cache. Let me uncache. And let me run this again. hide the options. So basically, I'm looking again for the same happiness in the article, and I'm running that for the entire database, entire data set I have for this year. And I'm doing on each of the titles a regex. So regex, it's not so straightforward. You actually have to look into the data, and you can't use an index or things like that necessarily. So what you see here, I processed 1 terabyte of data in 20 seconds. Now we have actually demos where we process petabytes of data in under a minute or around a minute. So BigQuery is really, really powerful in processing vast amounts of data, and you pay basically for the data that is processed. All right, in terms of resources and related sessions, where can you find out about pricing? So we have a pricing calculator on our webpage. It's cloud.google.com/product/calculator, where you can choose between the different products and size them, and then you get a price, basically an estimated price, what you're going to pay. Another thing that I want to mention is that we have a free tier. We have always free tier basically for products until otherwise stated, but for now it's always. It's basically every month that you get a free tier, and a lot of the products that I mentioned today actually have a free tier, so you can try them out. And even if you write a small app, you could end up paying nothing and running that application. So consider that if you want to check out GCP. And then in terms of sessions to look into, I have a couple that I recommend to look if you care about costs and keeping costs under control. So first is the managing costs in GCP. It's talking about the structures that you have to manage costs in GCP. Another one is about controlling. So that one was yesterday. It's recorded. It's on YouTube, so you can check it out on YouTube. Another one is controlling cloud costs with GCP and finance governing. That one, again, was also yesterday. It's also recorded. I would look into. Then we have one on monitoring and forecasting, as well as how to look into your billing data with BigQuery and Data Studio. So the one BigQuery and Data Studio is happening right now. So again, you need to use YouTube to check that out. And then we have one tomorrow around monitoring and forecasting on GCP.